Good afternoon, sir. This is Sarati. Myself is Srimati. This is Soundarya. This is Shishti. We are doing capstone for microcontroller laboratory course for 20274. In this, we have done project under the name motor control using LPC2148, and we have used servo motor.
Now we are going to see the code explanation and the simulation part that is being done in KL Vision 4 and Proteus 8 Professional.
Okay, this is the code for controlling servo motor using LPC2138. If we are doing in kit, we can go with LPC2148, and as we are doing the demonstration in Kale Mu Vision 4 and Proteus, we are doing it with LPC2138. So the first step would be header file. This header file includes all the special function registers of LPC2138 microcontroller, so that there would be direct register access for the given registers inside it. Then the second part would be delay function definition. So here, depending on the value of ms, delay is produced. So if we are giving a value of 1 to the ms variable, there would be a 1 millisecond delay generator. Depending on the value of ms, the delay value is getting varied. So coming to the next function, it is PWM initialization. Nothing but we are initializing the PWM function. So here initially the first statement or instruction is for clearing the bits of the 21st bit of port 0 if any other value is present already. The pin select 1 is used to configure all the pins from 16th bit to 31st bit of port 0. So the second instruction would be for setting the port 0 21st bit as PWM. So the next would be PWM control register. This enables the pin as output. Then the next part would be a match register. It determines the period of PWM. Then comes match control register. If the bit 1 value is 1, counter resets when it reaches the MR0 value. This is used for resetting the counter again when it reaches the MR0 value. Then comes timer control register. When the first bit is 1, the timer is reset to 0. Then next comes the same control register. This is used for enabling the pulse width modulation and timer. In the last register here, it is known as latch enables register. The 0th bit of this latches the MR value into the shadow register. Now coming to the third function, that is set servo angle. This is used to defines the function to set servo position from 0 to 180 degree. So it maps the angle to a pulse width. So for this, when the angle is 0 degree, the pulse width would be 2500, and when the angle is 180 degree, the pulse width would be 7500. Okay, this linearly converts angle to pulse width modulation. Then next would be match register 1, which calculates the pulse width on time. Then would be PWM LER. This is used for latching the new value of MR1. Now coming to the main function. This main function is used for defining and working on all the functions that are defined already. So the first register is used to give the input to the peripheral clock, which depends on the CCL clock. So if since the bit that is set for this is 0 cross 01, the PCL clock is getting the value same as CCL clock. Then we are defining, then we are calling the function PWM in it. Then comes we are calling in indefinite for loop, while loop. We are going for setting the servo angle, like we are calling the function set servo angle, which is used to determine the angle. Then a delay is being a delay function is called. Then again the angle set servo angle function is called for 90 degree, and again delay is being called. Again for three different values set servo angle is being called function, then delay function is called. So now let's compile this code and create a hex file so that we would be able to import this in Proteus 8 Professional. For that, first we need to add the existing file which contains the same file name, and we should save this file actually with .c extension since this is a C code. Then we need to for the first we should give us create hex file, then build, and here we can see that hex file is created. So now we can go to Professional and we can import this file.
Now let's see the servo motor interfacing with LPC2148. Where we have used several components for this. We have used crystal oscillator LM1117MP3.3 and LPC2148 and servo motor. Now let's see the connections. The crystal oscillator is connected to the LPC2148 via 62 and 61st pin. Then it is connected to 22 picofarad capacitor for stability. Then LM1117MP3.3 is connected to the LPC2148 via 10 microfarad capacitor for stability and a 5 volts power supply for the LPC2148, and the VBAT pins are connected to the 10 microfarad capacitor of LM1117MP3.3, and VSSA pins are grounded in LPC2148, and the stepper motor is also grounded. 47th pin of the LPC2148 is connected to the servo motor. Then a 5 volts power supply is also given. So this is the simple connection explanation of servo motor with LPC2148. You can use any of the PWM pins for connecting a servo motor to the LPC2148. Here I have used 47th pin. Hope you are clear. Then next we can move how to interface the servo motor with LPC2148. Double click the LPC2148 and add your hexa file to it. Now your file is interfaced with the servo motor and LPC2148. And when you click on the run button, your motor starts running. Now let's see the output. Click on the run button. I think you can see that your motor is running. It runs up to minus 136 degree, which is anti-clockwise direction. I will zoom and show you for your clear reference of the output. Yeah, now you can see it clearly. The servo motor can run up to 160 degree in real time. Due to Proteus limitations, it run up to 136 degree here.
Hope you're clear with the connections and how it works in overall. um, Thank you. um, let me know if you have any doubts in the comments. Thank you.